when did the concepts and terms of statistics become systematic? What comes to mind first when we think about statistics? Difficult terms such as average, graph, standard deviation, and normal distribution may come to mind. However, these terms did not exist from the beginning. So when did the concepts and terms of statistics that we use today begin to develop? Until the 18th century, statistics was closer to a field of political study. In fact, the word statistics comes from the Italian word statista, meaning statesman. The word census also comes from censor, an official in ancient Rome who conducted population counts. At that time, Britain and Germany argued for many years over who should be called the father of statistics. Britain recognized William Petty, who wrote Political Arithmetic, as the founder of statistics. Germany, on the other hand, recognized Gottfried Achenwall, who wrote on Staatswissenschaft, as the founder of statistics. But today, people think of statistics as the language of science rather than politics. The person who had the greatest influence on this change was the British mathematician Karl Pearson. Pearson said that if science is a language, then statistics is its grammar. Just as no one can write proper sentences without grammar, science cannot reach accurate conclusions without statistics. In fact, it is said that even Albert Einstein read Pearson's books in his youth and dreamed of becoming a scientist. So, how did Pearson become a statistician? Interestingly, his starting point was biology. His research took a new direction after he met the zoologist Weldon. Weldon then introduced Pearson to Francis Galton, Charles Darwin's cousin. Galton was studying how height is inherited from parents to their children. While conducting his research, he discovered an interesting fact. Children of very tall parents are often not as tall as their parents, while children of very short parents are often a little taller than their parents. In the end, he found that extreme results tend to move closer to the average over time. This is called regression to the mean. Galton also introduced another important concept. It was correlation. For example, when study time increases, test scores often improve. On the other hand, when exercise time increases, physical fitness is more likely to improve. This relationship, in which two things change together, is called correlation. However, knowing that a relationship exists does not tell us how strong it is. So Pearson developed the correlation coefficient to express it as a number. The correlation coefficient ranges from -1 to 1. The closer it is to 1, the more the two variables move together. The closer it is to -1, the more they move in opposite directions. If it is close to 0, the two variables have little or no relationship. Today, this method is still widely used in fields such as medicine, economics, sports, and artificial intelligence. Pearson also developed another important concept, the standard deviation. The standard deviation shows how far data is spread from the average. For example, suppose the average score of 10 students is 50. In one class, all 10 students scored 50. In the other class, 5 students scored 0, and the other 5 scored 100. The average score of both classes is 50, but the test results are completely different. Like this, the average alone cannot fully explain the data. Looking at the standard deviation together shows how evenly the data is distributed. Pearson also popularized the histogram to represent data visually. A histogram is a graph that displays data with bars. If the bars are tallest in the center, the data are concentrated around the average. On the other hand, if the bars spread widely, the data are also spread out across a wider range. A single graph can make the characteristics of data easy to understand. The graph most commonly seen in statistics is the normal distribution. It has a bell-shaped curve, with the highest point in the center and lower values toward both sides. There are many examples of the normal distribution around us. Most values cluster near the average, while very large or very small values appear less often, such as people's heights and weights, test scores, and the sizes of fruits. Interestingly, the normal distribution was not created by a single person. The French mathematician Abraham de Moivre first proposed the idea. The German mathematician Carl Friedrich Gauss developed it further, and the French mathematician Pierre-Simon Laplace continued the research. Later, Carl Pearson chose the name normal distribution instead of naming it after a single person so that everyone could use it. The average, standard deviation, correlation coefficient, histogram, and normal distribution that we learn today all grew out of mathematicians' efforts to understand the world more accurately. When looking at a graph or statistical data in the future, do not think of it as just numbers. Instead, ask, what story are these numbers telling us? Statistics is not just a collection of numbers. It is another language for understanding the world.